So here are two special cases that show up when we're writing equations of lines. We knew these were special cases when we were learning how to graph lines. The first special case is a horizontal line, right? There's a couple of ways we can look at this. I'm going to show you both ways. The first way I'm going to show you is the way that will work for horizontal and vertical lines. If you notice, on a horizontal line, one of the coordinates never changes, right? The coordinates of this point are -3, 2. The coordinates of this point are -1, 2. This point is 2, 2. Ha ha ha. And 1, 2, 3, 1, 2, 3, 4. And the coordinates of this point are 4, 2. Okay? What do you notice? In every one of these points, the y coordinate is the exact same thing. So what is the y coordinate of every point on this line? The y coordinate is 2. So that means the equation of this line is y equals 2, because every point on this line has a y coordinate of 2. Okay? Easy enough. The other thing you can do is you can use slope-intercept form here. If you look and remember, what's the slope of a horizontal line? Do you remember? The slope of a horizontal line is 0, right? This is 0 fun. Where does this line cross the y-axis? Well, this line crosses the y-axis, guess what? At 2. So we could say y equals 0x plus 2, but 0 times x is just 0, and 0 plus 2, guess what we get? Y equals 2. So that one you can sort of look at both ways. A vertical line, like we're going to look at next, it doesn't work in slope-intercept form because its slope is undefined. So we have to look at the coordinates of the point, but it's going to be very similar to the horizontal line. If we pick a few points here, the coordinates of this point are -3, 3. The coordinates of this point are -3, 1. The coordinates of this point are -3, -2. What do you notice? The x coordinate has the same value for every point on this line. Every point on this line has an x coordinate of -3. So the equation of this line is x equals -3. So a y equals a number, like we got right here, is a horizontal line, and x equals a number is a vertical line. You might remember, it's been a while, but you might remember we talked about HOI, right? Horizontal line, 0 slope, y equals, and then we talked about VUX, right? Vertical line, undefined slope, x equals. So those are your two special cases from a graph. Now, the special cases from a table. Look at your table before you start and see if there's anything weird, anything notable about the table. And I look at this table and I notice my x values are all 5. 5, 5, 5, 6, 5, 7, 5, 8. If we were to graph this, and you don't have to graph it, but if we were to graph it, we'd go over 5, up 5, over 5, up 6, over 5, up 7, over 5, up 8. What kind of line are we going to get? We're going to get a vertical line. What is true about every point on this line? X equals 5. Done. We didn't have to find the slope. If you'll notice, the y-intercept, well, there's not one, but it's not in the table. And since they showed us that every x value is 5, the equation is x equals 5. Now, over here, I look at the table first before I do anything. I could find the slope. I look and I say, they didn't give me a y-intercept, but look at that. Every y value is -4. What do you think the equation of this line is? Y equals -4. Just make sure you pay attention to whether the y's are staying the same or whether the x's are staying the same, because that will let you know whether to use x or y in your equation.